All right,
And good angle?
we're going. Yeah, I think it's good. I think so. I think I can stick to this board if all I'm doing is review problems. So, okay, number 25. We are going over parametric forms of conics and the directions where find the rectangular equation of the curve whose parametric equations are given, then graph the equation using arrows to indicate orientation, which I was calling direction. 25 says, starts with x equals t, y equals 2t squared minus 4t, and we're going, infinity is all real numbers. This one, no, I think I know what you're asking about this one. You've said before that you miss some Algebra 2 stuff. If it's all real numbers, okay, if x equals t, we can do a simple substitution. Put x in here. Y equals 2x squared minus 4x.
Isn't there a plus 1 or something?
Let me double check. Am I misreading it?
It's 2t squared minus.
Oh, yeah.
4t, plus 1. Oh, that does make it a tiny bit more exciting. That would have been very much easier to graph. Okay, so this is a rectangular parabola. Unlike the conics we just did, it's an ax squared plus bx plus c form. Graphing it, we can review some tricks for graphing it that we would have reviewed earlier in the year if I didn't rearrange the order of this course to match physics. We don't have to graph this over a set interval. It goes on forever and ever, but we do have to indicate direction. So let's see. What do we know about this? Let's start with the somewhat easy things.
It's going to be a positive y.
How do you mean?
It's going to go.
You mean the direction when we put in the arrow?
It's going to be up. Like that one, right above you.
Well, it's going to be smiling. Hold off on that, so I'm not sure whether you're talking about which way it's oriented.
It's smiling.
Yeah, it's going to be a smiling parabola. Because this is positive, it's going to be smiling.
Well, because the other one was negative.
What's its y-intercept? Let's start figuring out some stuff about it. What's its y-intercept?
1.
0, 1, but yeah, 0, 1. If I put in 0 for x, if I ask myself what is f of 0, I get 2 times 0 squared minus 4 times 0 plus 1. So it passes through the point 0, 1. How do we find out if it has any x-intercepts?
So y to 0.
Set y to 0 and then just solve. What is the trick? We haven't done this at all. This is funny. This is a book assumes that you've seen this
Except if it has a
recently.
y-intercept at... Wait. No, maybe not. I don't know.
All right. This goes, I'm going to give you this one. This one goes back to the quadratic formula. This is that case where you pull that out, which you guys haven't done probably since fall before last.
No, we did it in Algebra 2 a little bit.
Okay, that would have been fall before
But it was
this
only like
last
for
one.
certain instances, like if this doesn't work for this,
Right.
then you can do the quadratic formula.
Gotcha. And then physics, we did a lot of it.
How do you do it by
Last
hand?
There may or may not be a good way to do it by hand, but can I hold off on that because we're going to go over that probably in 2 weeks. So we'll get to this. Quadratic formula is going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What's the first thing you do in the quadratic formula before you waste time with anything else? You guys remember something called the determinant or discriminant?
Determinant.
Thank you. I think so. So it's
Yeah, I don't remember to do
you check b squared minus 4ac, which in this case is negative 4 squared. Please make sure you use the parentheses if you pull out a calculator. Minus 4 times 2 times 1, which gives me
16 minus 8, so 8.
yeah. It's positive. If this number is positive, then the plus or minus means you're going to get 2 solutions. If this number is 0, the plus or minus means you're going to get 1 solution. And if this number is negative, you don't have any real solution because I pops in and we're not dealing with the imaginary plane in this unit. So x is therefore going to be negative b, which is negative 4, plus or minus the square root of 8 over 2 times 2. So that's 4 plus or minus square root of 8 drops down to 2 root 2, I believe.
Okay, how did they do it?
Negative of a negative is a positive. 8 is 4 times
that's
2.
the first thing
plus
you
or
did.
minus.
Why is it b
2 over
squared minus 4ac?
It's the part that's under the radical. It's the first thing you check. Tells you right away if you need to go on. For example, what if I'd done b squared minus 4ac no, and the answer was negative? I'd have a negative under the square root, and I'd know this parabola had no x-intercepts. Again, we're going to review this in about a week and a half, so hold off for now on this one. And so
what is this determinant telling us? Or just remember?
well, this part, well, sorry, so we were done with that back here
Okay.
with the positive 8. This told us we have 2 solutions. Then we put the 8 back in for b squared minus 4ac,
Okay.
and these solutions are 4 plus, as Joey said, I can pull a 2 out of each term on the top and reduce it with 4 on the bottom, and that's 2 plus root 2 over 2, or 2 minus root 2 over 2.
Wait, couldn't you just do like 1 plus root 2 and then 1 minus root 2?
Factors versus terms.
Root 2 over 2, sorry.
If
1
you're
plus root 2 over 2.
now
and
we
one
can,
minus
yes, we could absolutely do that.
Yeah.
If you like that better, we could do 1 plus root 2 over 2, or 1 minus root 2 over 2. So to graph this, I think 3 points is good enough for now. You guys remember how to find the vertex?
It was like negative b over 2a or something.
Very good. The vertex is
Oh,
actually
Joey.
this part of the quadratic formula. So for the vertex, the x-coordinate is negative b over 2a. The y-coordinate is whatever you get when you put negative 2b over 2a back into your function, back into your parabola. So, negative b over this case. I'm also looking at finding the x-intercepts. Looking at these x-intercepts, is there a shortcut for finding the vertex? How does the vertex relate to the x-intercepts? If you have 2 of them. Okay, hold that thought a sec. I'm going to give you a little bit of information here. Here's 1 on the x-axis. Okay?
Oh, so then, because then 1 is the
Tell me something about the vertex and the 2 x-intercepts.
The vertex is right in the middle.
Vertex is right in the middle. 1 plus root 2 over 2, 1 minus root 2 over 2. What's in the middle between those two? 1. Vertex is 1 something. I plug 1 back in, so the vertex is going to be 1. Better be what I get, like 2 negative b over 2a after I said that. Yes, that is. Okay, it's going to be 1, and then if I put 1 in for x back in my original parabola, thank you, Jen, I get 2 minus 4, which is negative 2 plus 1, I get 1 negative 1. Again, because I've told you guys so many times that without a calculator back in high school, I had to know root 2 over 2 was about 0.7. I go down to about 0.3, I go up to about 1.7. And this is the graph of y equals 2x squared minus 4x plus 1. That was a nice review of Algebra 2 and the stuff we're going to be doing when we go back to that in a couple weeks.
Wait, why did it go up 1 point? Oh, so what was p? Do we have?
Oh, that you're thinking in terms of conics, and this is just this is just treating it as a function.
I don't know.
Gotcha. Okay, I know, we're going to go back and review it. Don't worry about that. Okay, so y equals 2x squared minus 4x plus 1, and this is enough information. If this were an Algebra 2 problem, we'd be done, but this wasn't the original question. The original question was the parametric problem, x equals t, y equals 2t squared minus 4t, and over here is where I left off plus 1 originally. Only thing we need to make this one parametric instead of rectangular is give an idea of which way our imaginary particle is going. If we plug in t values and the t values go up, does the spot on the parabola go this way? Does it go back that way? As x increases.
Go up because that way, doesn't it?
Yes, I wish our audience at home could see the correct gesture you made. But yeah, as x increases, in this case, as as t increases.
Wait, so is that always like considered to be like the direction of the parametric?
Yeah, as t goes up. Parametric equations' overwhelming use is for t to be time, and we usually talk about time moving forward as the graph goes from left to right. There are reasons to switch that sometimes, but I don't think we're going to get to any. So as t increases, we move right to left.
Wait, left or right?
Yeah.
You guys could learn so much more if your teacher wasn't occasionally dyslexic. Which way do we read in English?
Left to right.
That's a rumor. Okay, so you're not done with this parametric equation until you do that. And this is a parametric conic, but treating it like in the x squared equals 4py or format probably wasn't the most helpful way to do this. Treating this like an algebra 2 problem is probably better. All right, any questions on this one? And don't worry if you struggle with the algebra 2 part. I'll help you out with that, because I know one of you took these classes out of order. All right, let's take a look at 22. Jen, if you follow me back this way, I will start erasing this. Let's see what 22 said. Okay, so this was, God, another parabola. I like the other ones better.
This one you didn't have to graph it though.
Oh, okay.
Or I assumed we didn't because on the homework, those numbers you told us not to graph, so.
Oh, that was the night before. Yeah, this one, this was from the night before. So what were my directions on this one? Do you remember?
Your directions were.
Just identify?
No, identifying wasn't. You were also supposed to. Well,
Write it
I
in
don't
standard
know.
form?
Other people said you were just supposed to identify, but I thought you were supposed to write it in standard form, which is what I had trouble with.
All right, well, let's do both. But let's try to identify it first. Anyone have any idea what this thing is and why?
It's a parabola.
It's a parabola. Because if we,
There's no a value.
bingo. If we were looking at ax squared, we are looking at ax squared. Let's do the whole thing, so that starts tomorrow. Plus bxy plus cy squared plus dx plus ey plus f equals 0. Good. Okay, then in this case we have no xy, so as I've hinted at before, that means it's not rotated. We'll start rotating them tomorrow. We don't have an ax squared either, so in the absence of either a or c, you are looking at a parabola, and f is on the other side. So now, getting this into standard form, I would first factor the 4 out of the y squared and the y, and I would set that equal to negative 8x plus 15. Any questions
that's
on
what I did wrong. I did set it up in parabola form.
You just tried to do it in ellipse and hyperbola
Yeah.
form. That will do it. Here's the fun part that does come up on this one that you might have run into either way. Yes, if you tried to do got it. If you know, once you know it's a parabola,
Yeah.
you got to start setting it up like
Which
this.
number was this? Y
22.
22.
667.
plus 1/4.
1/4. Very good, Joey. In this case, to complete this square, we're going to have to deal with fractions because you cut 1 in half, square it, you get 1/4. And that means over here, what do I add to the other side?
1.
Joey says 1. You agree with
Yes.
that?
Wait, 1?
Yeah,
Because
because 1/4 times.
Okay, yeah.
We're not just adding 1/4, that's inside the parentheses. That 1/4 is being multiplied by 4, so we add 1 over here.
Oh, hey, but this kind of works out because, like, then at the end,
Somebody sees where that's going.
Joey.
So that's y plus 1/2 quantity squared, because this is the binomial that if you FOIL it will get you that 1/4 at the end, equals negative 8x plus 16.
Which if you, I think,
What do I get?
x minus 2.
X minus 2.
Oh.
Nicely done, sir. Joey, you just almost designed a car headlight that shined back in on the engine.
Which would have been useful.
That'd be great for the mechanic. Other than that, it probably wouldn't have been very useful.
I said x minus 2.
I tried to fix my own car headlights once, I almost did that. Okay, so what do I know about this thing? The vertex, won't graph it, but let's get its identifying information. The vertex is at positive 2, negative 1/2, and P is equal to negative 2, because it's negative 4P. And so from here we could figure out, it's not like 2. From here we could figure out where the focal point is and where the directrix are. It's the y is the thing that's squared, so it is going left to right. P is negative, so it opens to the left. So the focus is 2 units to the left of this point, and the directrix is 2 units to the right of this point. So that's number 22. Any questions on this? Going once, going twice. And I'll start number 30 right here. Okay. 30. Find the rectangular equation of the curve whose parametric equations are given. Oh, this one's going to be fun. X equals 2t minus 1, and y equals square root of t, and we only care about t from 0 to 4, including both? Including both. That's square root of t, not square root of 2. That's a very different graph. We have to get t by itself, and we want to do it in a way that's helpful. First off, you know what shape you're going for? What shape this is going to wind up? This whole section's on conic, so it's either an ellipse, a parabola, or hyperbola. Now, what did the ellipses and hyperbolas have?
Was this,
They had denominator? No.
Well, that's in standard
Yeah.
form, but in parametric form, they had something very distinctive about them.
x over y?
I
Oh,
still-
sine and cosine.
Sine, cosine, secant, and tangent. They had trigonometry. Remember, the ellipses were all x equals sine or cosine, y equals sine or cosine, and the hyperbolas were all secants and tangents in a very specific arrangement, or one of several very specific arrangements.
So this is parabola.
If it's a conic, it's a parabola, and this unit is not that going to throw a non-conic in. So by process of elimination, we're looking at a parabola. How do we know that? Well, here's the tricky part. Knowing we're looking for a parabola, well, what's missing that we always see in a parabola?
The exponent.
The exponent. Which exponent in particular? 2. It's quadratic. It's by definition, a quadratic equation graphs a parabola and is a second degree equation. It always bothered me that quadratic has its root in 4 and parabola and second degree. They gave that name to second degree equations. I can tell you why if you're curious. All right. Okay, so in this case, I don't want to give this away, but does anybody here see how we can get both get rid of the t and get that second degree?
Y, so then t equals y squared, and then.
Oh, exactly wrong.
Oh.
Oh, I would have done that.
No, wait, you said it right. I heard you backwards.
Wait.
My fault. I'm so dyslexic today. So what, Jen, what does that look like? I want to hear you say it. I've heard you talk a lot today.
It's just y squared equals t. So then you can plug in like that for the top.
And what does
So
that get me?
X equals 2y squared minus 1.
Exactly what you were going to say, right, Joey?
Yeah.
That's what he said.
Whoops.
X is not squared.
Thank you, x is not squared. I got so excited with the exponent. Okay, so t equals y squared, so x equals 2y squared minus 1. So what are we looking at here? What sort of parabola? Where does it open? What is it doing?
It opens to the right.
Opens to the right.
How do you deal with something that divides? Because if you put the...
I think you're thinking of factors, but let's get, here's,
because x, wouldn't you do x plus 1 over 2?
oh, you're thinking about solving it for y.
So you gotta get the two things on each side.
You don't have to.
No?
You actually don't have, well, actually, what we all, no, you're right, we do. Sorry, because when we did this in conic form, I was about to say it's like a sideways function, it was always whatever was squared on the right, and that's how we found p. So yes, you're correct. So I'm going to change this to 2y squared minus 1 equals x. And then 2y squared equals x plus 1. And then that'll get me y squared equals, I'm going to write it a little bit differently
Ah.
than you suggested, as 1/2 times x plus 1.
Oh yeah, that's what I did, and that's how I found p, because p times, so it's 1/8, it's really annoying.
It is annoying. So if 4p is 1/2, then as Noah just said, p is going to be 1/8. And this parabola's vertex is at -1, 0. Because we have a counterintuitive shift with the x, and we have nothing with the y. Please stop. Here's the good point for me to stop and take questions.
Wait, so the -1, 0, where's that from?
That's your vertex. The x coordinate of your vertex
Yeah.
is you switch
Oh,
the
and because it's
counterintuitive.
just like the 0's not there. Oh, okay,
Bingo.
I see.
So this, yeah, you could write this as y plus 0 squared, but that seems silly. Right, so let's go ahead and graph this thing, which means I'll need to see a little bit on the other board. That should let me see what I want.
That'd be cameraman.
It didn't tell
sure.
us. It didn't tell us to graph it, but
I think didn't these directions say graph?
you said not to follow the
you
directions.
Oh,
said-
that was 2 nights ago.
Yeah.
Let's graph it anyway for practice and fun.
Well, I don't know about fun.
What could be more fun?
I've already done, I don't know how.
Alright, let's take a look at this thing. It's all in the scaling at this point, for one this annoying. I'm actually going to put, vertex is at -1, 0. I'm going to put -1 way out here. 1 up here. -1 on the y-axis there. And I think that'll actually leave me enough room. So -1, 0, here's my vertex. Now we did say this opens to the right, I hope. Yes, p is positive. Between -1 and 0. Is that a good guess for 1/2?
Yeah.
Is that a good guess for half of that? Is that a good guess for half of that?
Yep.
Am I down to 1/8 yet?
Uh,
1/2, 4ths, 8ths?
yeah.
Okay, then there's my focal point. 1/8 to the right. And my directrix will be 1/8 of a unit to the left of my vertex. Now we find the endpoints of the lattice rectum by going up and down twice the length of p from the focal point. 2p is 1/4. Here's my guess for 1/2 and -1/2 on the y-axis. Here's my guess for 1/4 and -1/4 on the y-axis. So I'm going to go that much above the focus and that much below the focus. My parabola should look something like that. Labeling everything, the vertex we already said was -1, 0. The single focal point is -7/8, 0. So if I only want 1/8 back from -1, that should only take me to -7/8. And the lattice rectum runs from -7/8, 1/4 to -7/8, -1/4. Since the focus is on the x-axis, it just goes up and down the same amount. And the directrix has the equation x equals negative 1 and 1/8, correct? 1/8 further to the left. I can write that more clearly. Any questions on that? Only thing we didn't go over any of the trigonometric ones, but I want to give you some time in class to work on this worksheet. So I will let you do that. And this will be available for you guys to review the parabola stuff.